So, Bhavyashri, are you there? You're asking doubts. Okay, I think one person, Bhavyashri. Okay, so we were discussing flexural shear flow or shear flow due to non-uniform bending in thin-walled structures. Okay, and we derived formula, right? So, what is the QS? The shear flow at any section? It is integration dou q by dou s ds, right? That is what the shear flow formula, and it came as what? Minus vx into ixx minus vy ixy upon ixx iyy minus ixy square, then integration x t ds minus vy iyy minus vx ixy upon ixx iyy minus ixy square integration y t ds. Clear, guys? This formula, am I correct? Is it correct? Now, guys, if your cross section is sorry, if cross section is symmetric, so for symmetric cross section, what we know, ixy is 0. So when your cross section is symmetric, what is your qs? It will be minus Vx upon Ixx integration x t ds minus Vy upon I, sorry, it is Vx upon Iyy. Okay, it is Vx upon Iyy, then minus Vy upon Ixx integration y t ds. Am I correct? Am I correct, guys? Now, guys, further, if if Vx is 0, your horizontal shear force is 0. So what is your Qs? Qs will be minus Vy upon Ixx integration y t ds. Correct, guys? So this is Vy. Okay. So, guys, in today's class, this formula is going to be very important for me. This is going to be an important formula because I'll be using continuously this formula mainly for C section. Okay, and in gate, one of the gate exam also they asked one of the problem. In fact, in 2023 paper also there is a problem from shear center and shear flow path. Okay, so guys, this is for thin walled section. Okay, now guys, if you see the idealized section, so in case of idealized section, guys, in case of idealized section, what will be this formula? In case of idealized section, in case of idealized section, if I write this formula along, what it will be? It will be, if I write here, it will be minus Vi upon Ixx sigma what T into ds is a, so it will be sigma a I y I. Clear? Oh, is it 2023 problem was directly from Maxon? Uh, I have not seen, but possible. But that question I have already, we'll discuss that question. Okay, that's good to know. Yeah, they follows TSG Maxon or Citizen only. Okay, books like TSG Maxon, Citizen, DJ Piri, and one more Brune. These are well-known author in aircraft structure. What are Brune? Brune. Have you guys heard about Brune? Aircraft structure by Brune. Okay, so Brune is most followed in industry as a reference. Okay, Brune. Aircraft structure by Brune. So that is like handbook. Okay, it's not like textbook. Handbook. Okay, Brune, but it is complicated. Okay, not that simple or more organized like TSG Maxon. And in Maxon, complete solution is available. And you all know, right? TSG Maxon was not aerospace engineer. What was his degree? Huh? Maxon was, what was the graduation course he has done? Maxon was civil engineer, okay? Or he was, or he, I am not sure. But Maxon is a civil engineer, okay? So you can see a civil engineer have written that good book for aircraft structure, okay? So Brune, then Maxon, and then DJ Piri or Azhar and Piri, okay, and this Citizen. So these four books are there. But in thin wall structure, guys, more of the questions in books are lengthy, so you expect they will formulate questions. Okay, usually they will formulate question. Now, guys, in this figure, one more thing. That day we discussed, right? Equilibrium, right? Here you can mention in this figure there will be complementary, right? So this part, like here, it is not drawn, but there will be complementary, right? Because shear stresses are always complementary. Yes or no, guys? Okay, fine. So let's start today's part where we left. I think we were solving questions. So all these questions we have solved. This also we have solved. That was last question. Now start with C section. Okay, because here first we will try to draw how to draw shear flow, and then we will start how to find shear center. So guys, when you want to find shear center, when you want to find shear center, you need not to apply both loads together. Okay, both loads means your Vx and Vy is not required to apply together. Just if you want to find the shear center position. How? If your cross section, see, I'll just tell you guys two things. If your cross section is like this, it is symmetric about what? It is symmetric about what? This C section is symmetric about x axis, right? X axis. So when it is symmetric about x axis, your shear center lies on x axis. So what is the position unknown for shear center? Suppose for any section, shear center is given by zeta x, zeta y. So what is this unknown in this for C section? Can tell me what is the unknown? Zeta x and zeta y. It's a zeta x is unknown, right? Zeta y is known, right? Zeta y will be 0, right? Because your shear center will lie on x axis. So zeta x is unknown. So when you have a symmetry about x axis, you need to apply only Vy to find the shear center position. Clear, guys? You just need to apply what? Vy, not both. Vy alone you can find the shear center position. I will tell you that. Now suppose guys you have a T section. Suppose this is a T section. Now tell me guys, it is symmetric about what? It is symmetric about y axis. Now what is the unknown position in this zeta x and zeta y? What is unknown? It is a zeta y, right? So this is 0, this is unknown. So to find this zeta y, what shear force you have to apply? Just Vx. Okay, and you can calculate the position for zeta y. Okay, so that's one fundamental. Now guys, in practical case, okay, in practical case, when you have a loading, there can be both Vx and Vy non-zero, and you may need to find the shear flows. Yeah, it is all whenever there is a symmetric section, shear center lies on axis of symmetry only. Clear? So this part is clear to everyone. Okay, when we have to apply Vx and when we have to apply Vy to, if in question it is asked find the shear center position, it will depends on the kind of symmetry it is. Now we have taken one example where you have channel section. Okay, the given problem is what? Channel section. Okay, now this channel section we know it is symmetric about what? It is symmetric about x axis, right? So the first place I will apply a force through shear center, okay, through shear center which is in vertical direction. I am assuming my shear center lies here. Okay, I am assuming it lies here. So this is shear center and we applied one shear force Vy, or they have mentioned Sy also. Okay, let's use Vy. Now guys, here if finally you find your shear center value from some reference, so from where we can mention here value? Either we can mention here value from what? This web, right? Or we can mention also from where? Centroid, right? Yes or no, guys? We can mention the value either from centroid or from web. So that is like in exam one question is there, you guys will understand. Okay, that part also. Let's we write values from centroid. So this is what your distance from centroid. Okay, that's one part. Now guys, to find this shear center, tell me guys one thing. Do we need to draw this complete shear flow or find the complete shear flow for this C section? Anybody? If you guys have done, then you guys will be knowing, right? Okay, so those who know this already, they will tell no, right? We do not No, even top and bottom is not required, Vijay. I will tell you. Okay, top and bottom also not required. Only just knowing one will be number. Okay, we will discuss later. So let's now start drawing shear flow. So I am mentioning this is as 1, 2, this point is 3 and 4. Okay. So guys, we divided this section in three parts: 1 to 2, 2 to 3 and 3 to 4. First we will draw shear flow. So to we know, right, for this what will be the shear flow formula for channel section? We have applied only Vy force, right? So what is the formula? And Ixy is 0 here. So it is minus Vy upon Ixx integration Yt ds. Am I correct? Now for section 1 to 2. For section 1 to 2. What is the Y value, guys? What is the Y value from centroid? You can see this total is H. They have given total is H and this width is B. So what is the Y value? Minus H by 2. Why minus H by 2? Why not H by 2, Mr. Ravi Teja? This is below what your centroid, so always you have to take care that. So it is Y equal to minus H by 2. Okay, now guys substitute this in this QS formula. So what QS 1 to 2, what we find? Minus Vy upon Ixx, then substitute minus H by 2. So integration minus H by 2. Now T is constant, right? Thickness is uniform, yes or no? Throughout, thickness is uniform, yes? Yes or no, guys? In this channel section, we have drawn uniform thickness. So you can take T out because T is not function of S. Okay. So what is minus H by 2 into ds? Now guys, 1 to 2 means we are going in this direction. Okay. We are going in this direction. Now if you integrate, what you get? H is again constant, right? H is a constant, so we can take out. So it is what? Vy into Th by 2Ixx. Now integration ds is what, guys? Integration ds is what? It is S. So this is what your variation of shear flow between 1 to 2. Now guys, at 1, what is the shear flow at point 1? Your QS is equal to Q1 and it is 0, right? So that means here there will be integral constant, right? When you integrate, there will be constant, right? Integral constant Q naught. So when you substitute this condition, what we find Q naught? What is the Q naught? 0, right? 0. So that means this is 0. Now guys, at point 2, at point 2, what is your S? What is your S? S is becoming B, right? So and your QS 1 to 2 will be what? Q2. So what will be your Q2? Your Q2 will be Vy T bh upon 2axx. Okay, clear? You guys got this value is clear? Yes or no? Q2 value. Everybody, 1 to 2 variation. Why Q1 is 0? Why Q1 is 0, guys? Because this is what the fundamental consideration. At open end your flexural shear flow is 0. Okay, now guys, 1 to 2 is clear. So next, do 2 to 3. So for section 2 to 3, for section 2 to 3, what is the y value, guys? So what is the y? If you write the variation, the value at 2, it is what? Minus h by 2. What is the value at 2? It is minus h by 2. Then your s, right? S is increasing. So that means it will be plus s. Now you guys can check. If you take point 3, what is the s? At point 3, what is the s? At point 3, what is the s? What is the value of s at point 3? It is h. So what is your y? Y will become plus h by 2, right? Y will become plus h by 2. Abhishek, you are considering section as s, right? So s is increasing from 2 and it is going till 3. So what is the s value? 0 to h, right? S is become increasing from 0 to h, right? Clear? So now is it clear? Okay. Now let's substitute this value in this shear flow formula, QS 2 to 3. So it is what? Minus Vy upon Ixx integration. So it is minus h by 2 plus s into t ds. Now again, thickness is uniform. I can take out. So minus Vy upon Ixx into t. Now integration. So what it will be? It will be minus h by 2 s plus s square by 2. Then integration constant q. Now this integration constant, how I will find? At in this s equal to 0, what is your qs 2 to 3, guys? It is q2, right? Yes or no, guys? And now what is the q2 value? We have already found. It is what? Vy tbh upon 2 Ixx, right? So guys, this value you can substitute here. So what is the variation? Qs 2 to 3 is nothing but minus Vy T upon Ixx minus Hs by 2 plus S square by 2 plus Vy Tbh upon 2 Ix. Now guys, if you look into this, I want Q3, right? So what is the Q3? When S equal to H, when S equal to H, what you get guys? Q3, right? So here you can write this QS2 to 3 will be Q naught, and Q naught is becoming what? Q2 in this case. Now guys, at S equal to H, what is your QS2 to 3? It is Q3. Now guys, tell me what will be the Q3? If you substitute S equal to H, what you get? When substitute H equal to S, you get this term as a 0. So your Q3 will be nothing but again it is Vy Tbh upon 2Ixx. Am I correct? It is nothing but equal to Q3. Now guys, what is this variation? If you see, this is what kind of variation? Quadratic, right? Parabolic variation. Okay. And if you see the previously, what is this variation guys? QS1 to 2, it is what? It is linear variation. Okay. So now last we do section section 3 to 1. Sorry. Section we have done 2 to 3, right? So 1 2 3 4, right? So 3 to 4, section 3 to 4. So what is the y value for section 3 to 4 guys? What is the y value? What is the y value for 3 to 4? It is positive h by 2 because it's above centroid. Okay. So guys, now what will be your QS 3 to 4? It will be minus Vy upon Ixx integration h by 2 T ds. Okay. Again, you can take h by 2 T out and integrate. So what we get? Minus Vy h T upon 2 Ixx, then integration ds means s plus constant q naught. Now how you will find constant q naught? When your s equal to 0. How your s is varying guys? To 3 to 4, it is like this, right? Now when s equal to 0, what is the qs 3 to 4 guys? At s equal to 0, your q s 3 to 4 is what guys? Q3. And now from here what we get? What we get guys? Q3 will become Q naught. Okay. So that means if you write your equation Qs 3 to 4, what it will be? It will be minus Vy Ht upon 2Ixx into S plus Q3. What is the Q3, guys? It is Vy Tbh upon 2Ixx. Is it clear, guys? Yes or no till now? How I have found this QS 3 to 4? Now, guys, at S equal to B, at S equal to B, what is the QS for? QS 3 to 4, it is what? It is Q4. Now substitute, guys, S equal to B in this equation. What you get? What you will get? When you substitute S equal to B, what you will get? You will get 0. So shear flow at Q4 is 0, right? What is the Q4? What is the point 4? It's a free end, right? Yes or no, guys? It's a free end, right? So you guys can see, if you see your shear flow distribution, it is 0 to linearly increasing, okay? Then it is parabolic, and then again linearly decreasing. So this is how your shear flow diagram. Clear, guys? Yes or no? Here it will be maximum. Everybody, how we have drawn shear flow diagram for this channel section? So this S is a local coordinate. Shivendra Raj, everybody, we are considering this S. S is a local coordinate, like 1 to 2 or 2 to 3 or 3 to 4. It is a local coordinate. Okay. Everybody, this shear flow diagram, is it clear or not? This is one of the gate question for channel section, how shear flow diagram look like, okay, in civil paper. Anybody have any doubt in this channel section? If yes or no, if no, then we'll proceed. Any doubt? Now it's confusing. Some people told yes, doubt is there. Yes, Parth, you can start from point 4 also. But if you start from point 4, then also your every quantity will be negative. You will get in negative. So that means you have to reverse the direction. Okay? If you start from 1 to 4, you can do it. So, any doubt, guys? Because in 1 to 2, S is independent of Y. Sorry, Y is independent of S. Y is independent of S in 1 to 2 and 3 to 4. It is constant. But in 2 to 3, Y is varying. Okay? So other people quickly respond to poll. I already explained now how I have selected Y for 2 to 3, Mr. Abhishek. See, if you take the section 2 to 3, right? Let me draw here. So what is 2 here, right? What is the Y value at 2? What is the Y value at 2? Minus H by 2, right? Now your S is increasing, right? From 2 to 3, right? Now if you take here section, what will be the Y value? Can you tell? What will be the Y value? It will be what? It will be minus H by 2 plus S, right? Yes or no? How it is minus H by 4? How do you know it is half? I'm not telling it is at half. I'm not telling it's a quarter point of H. I'm just telling any section. So how you find? This value we know, right? This is what S. So what will be the remaining? It will be minus H by 2 plus S, right? Clear now? Okay, fine. So guys, everybody must be clear how to, draw shear flow. Okay, fine. Now guys, next thing which comes to be shear center. So now can I erase everything? Can I erase everything? Okay. So you guys are understanding what I teach in this thin wall structure till now? All of you guys could understand whatever we have discussed from day one, from cross sectional properties or before. Ajinkya, is it clear? Whatever we have learned till now, Anwar, Amit, Anant, Harihara, Jayaprakash, Manjunath, Parthiamol, Kunal, are you getting what we are discussing? Okay. So guys, how many of you understand bending now better than previously? You guys have learned bending previously, and after starting this unsymmetrical bending part, how you guys feel, or physical feeling, or visualization of bending, and how to relate with mathematically. So guys, if you want to learn SOM, bending is most important, right? In strength of material and solid mechanics. And bending you can understand only if by equation, if you understand physically bending, okay? Or if you can visualize bending. Agree or not? You will do mathematically correct only live simple problem. I am telling, if somebody gave you some practical problem, if you understand how bending happens, how we can visualize physically, then only you can use the right equations or right mathematical formulation. Okay, now once you know this shear flow, the next thing which we need to find shear center. So how we find shear center plus, guys? First thing, tell me, guys. First one point I want to tell. See, guys, we applied here this shear, shear force Vy, right? In our problem, we applied shear force Vy, right? Yes or no, right? And we got some shear flow distribution, right? Yes, guys. Now, guys, this shear flow, this shear flow is resultant of this shear force. It is not what reaction of this shear force. Are you understanding my point? When you do beam problem, you find, right, reactions, right? At support, what you find? Reactions, right? When you find reaction, what you do? You suppose this is A, this is B. What you write, guys? And this applied load is like Q and length is L. What you do? You write like this: RA plus RB equal to Q into L. So you are doing what? You are doing, you are taking equilibrium, or you are equating, right? Force balancing, you are doing balancing. Okay, but in here it is not like this. It is not like this: Vy equal to this shear flow into something. It is not. I means we are not finding by balancing. This shear flow is not finding, not found by balancing. It is what? This shear flow is resultant of this applied shear force. Okay, so what I want to tell you, guys, when you find this shear center position, when you find the shear center position, you should not take what? Moment equilibrium. What you will take? In case of shear center, in case of shear center, we take what? We take moment equivalence. What we take, guys? Moment equivalence. This is one point which, like, usually people not clear. What we do? Moment equivalence, not moment equilibrium. Okay, so what you guys have to do? You have to take moment equivalence. Now what I am talking about, that, guys, to find this shear center position, to find this shear center position, to find this shear center position, you guys can take what? Moment equivalence. Okay, you guys can take what? Moment equivalence. Okay. Yeah, yeah, definitely I'll use different color. Okay, definitely black color I'll use, or red. So I'm just sharing, telling one thing. To find the shear center position, you have to take always what? Moment equivalence. Now, guys, what is the moment equivalence of? The moment equivalence means what? This shear force, you can take anywhere moment, right? You can take moment due to the shear force about like this point or this point, or you can take this point, this point, this point. About any point you can take moment, right? Yes or no? What? How we can take moment of any force? That force into what? Distance. Now I am saying that distance is what? This distance is some value zeta. Okay, so this zeta. Now what is the sense if you take suppose this point or you take this point, what will be the zeta, this moment, clockwise or anti-clockwise? See, this force is going up, so this moment will be like this, right? So it is creating what? A clockwise moment. Now when you talk about moment equivalence, when you talk about moment equivalence, guys, will you equate clockwise equal to clockwise or will you equate clockwise equal to anti-clockwise? Huh? Exactly, clockwise equal to clockwise. Okay. Now, guys, this is what the moment created by shear force. Now, guys, these shear flows, okay, if you multiply these shear flows, QS into section length ds, what it will give? If you multiplied QS into length, what you get? What you get? QS into ds is what? Shear force. Now this shear force multiplied by momentum, right? Now suppose, guys, you are taking this point. Let's take this point, okay, about which I am finding moment equivalence. So this point is what in your diagram? Point 3. Okay, so this is clear now. This perpendicular distance from this point is zeta. Yes or no? Now, guys, due to this force, okay, I want to take moment about this point, right? So what it will be? This QS into ds. What is this distance? Perpendicular distance. What is this perpendicular distance, guys? Because it is a horizontal member, right? So my force will be in this direction. So what will be the perpendicular distance? It will be h. Yes or no, guys? So about this point 3, what will be the moment direction, clockwise or anti-clockwise? See, this force is going in this direction, right? About this point, it gives me what? Clockwise, right? So it gives clockwise moment. So that means what? Now, guys, this is only for what? Small section, right? You want the total, right? So total means you need to integrate. You need to integrate from where? 1 to 2. So what is that 1? If you integrate, it is 0. What is that 2? It is b. So it is 0 to b, q s ds into h. So this is what your moment equivalence. Now, guys, what was the your QS 1 to 2? What was your QS 1 to 2, guys? We have discussed, right? QS 1 to 2, what it was? You guys know what is the QS 1 to 2? The variation of shear flow. What it was? It was VY T H S upon 2 I XX. Yes or no? This was variation, yes or no? Now, guys, this variation you substitute here, right? Because in this, what is your QS? QS is nothing but QS 1 to 2, right? Because we are talking 1 to 2. Now, guys, I will erase this. So what we find, Vy into zeta is equal to 0 to B QS 1 to 2 into H ds. Now put the variation 0 to B. It is what Vy T H S upon 2 I X into ds H ds. Am I correct? Is this correct? Yes or no, guys? Now further, your Vy, this Vy will get cancelled, right? So what you get? You get zeta equal to, I can take th square upon 2 ixx out. Then what we have, integration s ds, and this is 0 to b. Now guys, when you integrate, what you get, th square b square upon 4 I xx is what your shear center position. Am I correct? Is this correct, guys? Integration SDS is what, s square by 2, then 0 to b. So this is what your shear center position. Now guys, tell me, to find shear center position, do we require to find the complete shear flow? Do we require to find complete shear flow? No, no, right? Why? Why this 2 to 3 and 3 to 4 has not contributed? Can anybody tell? Why this 2 to 4 in moment equivalence? Why this 2 to 3 and 3 to 4 has not contributed? Yeah. So why we are not considering 2 to 3 and 3 to 4? Now guys, if you take 2 to 3, if you take guys 2 to 3, you can see your shear flow flowing like this, right? Now if you take shear force due to shear flow will be in which direction, guys? Suppose this is ds. So in ds into qs 2 to 3, right? Qs 2 to 3 is going in which direction, guys? So it is passing through what? It is passing through this point, right? So what will be the moment? What will be the moment? If your force is passing through that point, your moment is zero, right? That's why this is not considered. Now, Sam, this 3 to 4, why it is not considered? You can see this shear flow is flowing like this. So, what will be your shear force? It will be horizontal. Yes or no? This Q ds into Q s 3 to 4. It is going in horizontal direction. So, from where it is passing? Your force is passing through which point? Your force is passing through again point 3. So what will be the moment? 0. So that's why you can see it is 0 plus 0. So clear, to find shear center position, if you know properly shear flow for 1 to 2, section 1 to 2, it is enough. Now guys, now guys, suppose, suppose, now guys, suppose instead of that point 3, instead of point 3, if you take about this point, about this point, what you have to do, if you take moment equivalence about this point of same force, so what you have to do, you can do one thing, this is Vy into zeta, right? This distance zeta. Now guys, this shear flow as well as this shear flow both will create moment, right? Yes or no? But we can use the symmetry condition, right? this shear flow about this point will give me what, clockwise, and this also will give me about this point clockwise, and both the values are same. So what we do, we can use the symmetry condition and we can multiply by 2, then it will be 2 into 0 to b, then your qs. So what was your qs? It was vy t into th ds THS upon 2 IXX, then into now what will be your momentum, guys? What will be your momentum? H or H by 2? Exactly. So it will be H by 2 ds. Clear, guys? So this part is clear, everybody. How to find the shear center? So you guys can write this point, how to find shear center. In shear center, guys, you guys can write, finding shear center we use moment equivalence, not moment equilibrium, because the shear flow is what, the shear flow is not reaction of shear force, it is not reaction, it is what, resultant of, resultant of what, applied shear force. Okay, fine. So let's move to this gate question. Okay, this gate question. So what is given? Read the question, guys. Now Amit, Mr. Amit, Mr. Amit, not Amit, Abhishek, and some other people. Okay, let me erase this. You guys had that question, na? In last class we did, for this section when we put a cut, when we put a cut, while shear center position is varying, how you can find this? So for that I am giving you guys how to do this. You guys take this edge h and this edge b and take uniform thickness, uniform thickness. So what you have to do, suppose this is point 1, 2, 3, 4, 5. Now guys, what you do, you guys just find shear flow for 1 to 2, QS 1 to 2, and find QS 2 to 3. You guys can find, right? Find the shear flow and then take moment equivalence about this point using symmetry and find out your shear center position. Clear? Then you will find it is not coming here, right? Because when it was rectangle there was no cut, your shear center and for this closed section, right, your shear center and centroid was here, right? Yes or no? Now when you put a cut, these will not be at same place if you do mathematical calculation. So this point is clear, everybody? You guys understood how to find, yes or no? So what we can do, we will write Vy into zeta, that will be what, 2, then it will be what, 1 to 2. Okay, so 1 to 2 means what, it is 0 to h by 2. So it is what, Qs 1 to about this point. About this point it is going down, right? So about point this, if you take, it is what, qs1 to 2, okay, into ds. What is the momentum? It will be b, then plus 0 to b qs 2 to 3 into ds. What will be momentum? h by 2. Clear? How to find shear center for this case? Yes or no? After doing this, you guys put some numerical value. Take like h equal to some 20, b equal to 10, and t equal to 1. Mr. Abhishek and others. Guys, can you check this question? Guys, can you check? After doing calculation, you can put h equal to 20, b equal to 10, and t equal to 1. Okay, if you get zeta equal to, in closed section, what should be the zeta value? What will be the zeta value from web? In closed section, what will be the zeta value? B by 2. B by 2, mathematically we have taken 10, right? So it is nothing but 5. But in this case, find out. Okay, after substituting this, I believe zeta value will be some negative value. Okay, zeta will be some negative value, and it will be lying where? On this side, somewhere here. So guys, can you submit this homework? This is the homework I am giving, guys. Can you submit in the group? I already told guys, submit homework in group. Nobody have done till now. I have given homework for cross sectional property. Only one or two person send me doubt as a in person. See, I am sharing a simple question. In the previous question, you have a prepare see, yeah, this is the question, right? So I told for this somewhere here shear center will lie. So we now took as like this, just we rotated 90-degree to make it as like channel section, and I told this is h, okay, and this is b. They given this as a 2a, h is given as 2a. So h I have taken 20, b as 10, and thickness as 1 mm. You guys do calculation, find out the shear center position. Okay, so let's move to now the gate question of shear center from previous years. Yeah, so read the question, guys, what it says. The given thin wall section of uniform thickness T is symmetric about x-axis. Moment of inertia is given to be this. So ix they have given. They ask shear center for this section is located at. Shear center for this section is located at. So now if you look carefully this question, you can see this is what they given the reference, right? Origin, right? Because this is x-axis, this is y-axis, so this is what your origin. So from origin they want what is the position of shear center. Now guys, if you look this diagram carefully, okay, this section carefully, tell me, to find shear center position, if I give the nomenclature point, suppose this point is 1, this is 2, this is 3, 4, 5, 6, 7, and 8. Tell me guys, which all shear flow you require to find the shear center position of this section? Which all shear flow you require? Can anybody tell? To find the shear center position for this section, which all shear flow you require? 1 to 2, and 3 to 8 or 8 to 3. It is 8 to 3. Okay, it is not 3 to 8. We will write 8 to 3. I'll tell you the reason. If you go 3 to 8 now, you will have unknown at 3. So at 8, what is the shear flow at 8? What is the shear flow at 8? It's an open section, so 0. So we write 8 to 3 and 1 to 2. Okay, so guys, just you need 1 to 2 and 8 to 3. Now guys, so let's assume this is my shear center. Here again, I always consider left of the wave, and here we applied what? Vy. We applied Vy. Okay. Now guys, we applied Vy. So QS1 to 2. So for section 1 to 2 guys, tell me what is the okay, let me write first formula. For channel section, when IXY is 0 and VY only applied, what is your QS? Your QS formula is what? Minus VY upon IXX integration YT ds, right? This is the shear flow formula, yes or no? For channel kind of section, yes or no? Right. Now, guys, in this section, for section 1 to 2, what is the y value? What is the y value? Anybody? What is the y value? It is this value, right? So, what is this value? Because h or minus h? Minus h. It is below coordinate, right? So minus h. So you can see we are moving locally s in this direction and y equal to minus h. So now guys, qs 1 to 2, what it is? Minus vy upon ixx minus h t ds. Clear? Now guys, h and t are constant, I can take out. Okay, and when you integrate, what we get? Vy th upon ixx s. Then what will be? Integral constant, right? Integral constant, yes or no? Now guys, what will be the integral constant? At point 1, at point 1, at point 1, at point 1 guys, what is your s value? 0. And what is your qs 1 to 2? It is q1, and which is what? 0, right? So you, from here your what will be q naught? Q naught is 0, right? Q naught is 0. So if you see the variation q s 1 to 2, what is the variation is coming? It is or here if I write qs 1 to 2, my variation is what? Vy th s upon I x x. Am I correct? Is this correct? Mr. Sanjeev, is it correct? Okay. Now guys, 8 to 3. So for section 8 to 3, for section 8 to 3 guys, look, what is the y value for section this 8 to 3? What is the y value? What is the y value? Look in the diagram. It is minus h by 2. So what is your shear flow? QS 8 to 3. QS 8 to 3. What you find? Integration. You can write first this minus Vy upon Ixx integration. Now, uh, y value is what? Minus h by 2. Thickness is t ds. Again, if you see here, what we find? Vyth upon 2Ixx into s plus q naught. Now this integral constant, again in this case also it will be 0, because at free end we know your qa is 0, so your q naught is 0. Okay, so that means the variation of 8 to 3 is how much? It is Vy t h s upon 2 Ixx. Now guys, I want the shear center position. So what I do? I'll take the moment equivalence about what? This point, right? And I can use symmetry. Why I am not taking about this point, guys? Why I am not taking about point 5? Can anybody tell? Because if you take about point 5, you will require additional shear flows, right? 1 to 2, then 8 to 3, and then 7 to this also, right? So that means we can use symmetry here, and we will take at middle point this. So now guys, what is your, again, just a moment guys. So I want to find shear center position. So what it will be? It will be Vy into zeta. I am finding it from where? I am finding it from web and this center point. So I need shear flow for this and this. So again guys, when you go this 1 to 2, we what we take? First we are using the symmetry, so I will apply 2 out, then 1 to 2. So what is your shear flow? QS 1 to 2 into ds, my force. It is going in this direction. Okay, in this direction. What is your momentum? What is the momentum guys? QS 1 to 2, momentum is what? H. Okay, now guys, 1 to 2 is going in this direction. About this point, it gives me what? Clockwise or anti-clockwise? And first Vy into zeta, it is what? Clockwise or anti-clockwise? It is clockwise. Now guys, this 1 to 2, about this point, is clockwise or anti-clockwise? It is again clockwise, right? So I have to what? Use positive. If clockwise, because it's a moment equivalence, right? So clockwise equal to clockwise. So it is 0 to, what is your length? 0 to h, then qs 1 to 2 into h ds. Am I correct? Or you can write qs 1 to 2 ds into h in a better way. Just a moment, guys. One moment, guys. I'm facing some zoom. So 0 to h, qs ds is force into h momentum. This is for what? This is 1 to 2. Now, guys, what about 8 to 3? 8 to 3. Now, guys, look into 8 to 3. Now, if you look into 8 to 3, your shear flow is flowing in this direction. So, what is your force direction? This direction, which is what? Qs 8 to 3 into ds. What is the momentum? What is the momentum, guys, for this? The momentum is what? H by 2. Now, guys, this is what, in which direction? This force into this momentum, clockwise or anti-clockwise? This will give me anti-clockwise. So, if it is counterclockwise or anti-clockwise, what will be here sign? What will be here sign? Because you are equating, right? Clockwise equal to clockwise. So, it will be minus 0 to, what is the value? The length of that is how much? H by 2, right? So 0 to h by 2, and then qs 1 8 to 3 ds into h by 2. Now, guys, substitute here value. What we get? 2, 0 to h. What is your qs? 1 to 2. Qs 1 to 2 is how much? You already know, right? Qs 1 to 2 is how much? It is this value. Substitute vyths upon ixx. So it is vyths upon ixx into dsh minus 0 to h by 2. What is the qs 8 to 3? It is vyths upon 2 ixx, then ds into h by 2. Am I correct? Are this correct? Now, guys, vy throughout can be cancelled. So what we find here? 2. Now I will take this th square out. Okay, so it is th square upon ixx, then integration, it is s square by 2, 0 to h, then minus, from here what we can take out? T h square by 4, then integration, it is s square by 2, and it is what? 0 to h by 2. Am I correct? Are this correct till now? This simplification is correct, guys? Then further guys, it is 2 out. So what you find here, it is T h power 4 upon 2 I x x minus, you get T h power 4, then you get how much? 16. Am I correct? H is 8, so 4. 32, right? 32, yes or no? 8, 4, 32. Yes. So 32. So now guys, if you take LCM, what you get? Yeah, IXX. Here also IXX. Okay? TH square by 4 IXX. So 32 into IXX. Now guys, further you simplify, what you do, you can take 32 LCM. So what you get? 15 by 16, right? Yes or no? 2 will get cancelled. So when you simplify, it is what? 15 by 16 th power 4 upon ixx. Yes or no? Yes and no? Everybody, 15 by 16 th power 4 upon ixx. Now guys, ixx is already given. They have given the ixx, right? So here zeta will be what? It is 15 by 16 th power 4 upon ixx, right? What is the ixx value? They have given, what is the ixx value guys? It is 30 by 35 by 12 THQ. So 35 by 12 THQ. So how much we guys get? 7 5 is 35. So 3 4. So we get how much? 3, right? So 9 by 28 H. Am I correct? Now this is which side? This is which side guys? On negative x-axis, right? It is which side? Negative, right? So if you write in terms of the zeta x, what it will be? It will be minus 9 by 28 h. Why minus sign guys? It is on negative x-axis. So what is your answer guys? What is your answer? B is the answer. B is the answer. So everybody, it is clear how to find this shear center. What last part? Substituting value or Shivendra Raj, what last part? Here negative. Oh, why this last part negative? Okay. So now I can erase and tell why it is negative. Okay, let me erase a few part. This part. See why it is negative. You can see why it is negative. This is the given section, right? You are finding from this point and you have taken this is positive, right? You got this is positive, right? But if you see that in actuality, this is lying on what? Positive or negative x-axis? Because this is the coordinate they gave. So where? It is negative, right? So it is on negative x-axis. So that's why x is coming as what? Minus 9 by 28 h. Clear? Okay, so let's move to yeah. So if see this problem from yes, Sanjeev, quickly your doubt. What is your doubt? Where you have written above? Sir, open section does shear center always lie outside? How do I know that where I need to apply? See, you can apply anywhere, but usually you have right when you will apply Vy, when you will apply Vx based on symmetry. Now suppose one guy told me, ki, okay sir, I'll not apply here. I'll tell you can apply here na. Next problem we are going to see that only, Mr. Sanjeev. They have applied inside. So that means what? You will take this zeta. Now what will be this moment about this point? Clockwise or anti-clockwise due to this? It will be anti-clockwise. That's it. Then you have to use every moment anti-clockwise. If something is clockwise, then you have to put negative sign. So that means if you take like this, that means what? That means this will be reverse, then this will be negative, this will be positive. Then finally what answer you will get? You will get here negative sign. Clear na, Mr. Sanjeev? You will get negative. So that means what? That means instead of shear center here, it is negative means it's lying here. Okay? Everybody, is it okay? Okay, let's move to next question. Yeah. So in this question, the good thing is what they themselves gave the shear flows. Okay, but it is a closed section. It is not that easy to find for closed section. When if you have to find shear flow for closed section, and if it is not symmetric, then what? If it is closed section and you have to find shear flow. This is GATE 2023 problem. That's what I'm telling. It's easy problem. It's not a tough problem if you know the concept. No, cut is required if shear flow is not given. In this question, they gave shear flows for all the section. So will not require to cut. But in case in your GATE exam, I think in Magazine book, you can see this kind of question. So suppose this is the question and you have to find shear flow. Okay, for applied shear force, what you have to do? You have to make a cut and then you have to solve as a open section. Then this unknown Q naught you have to find using what? Your torsional shear flow part. Yes or no? Anybody have done this exercise in your engineering exam? It's quite lengthy, so we are not going to do. So in your examiner also understand. They gave this closed section, but they gave what? Shear flow already. So read this question, what it says, guys. Read this question, what it says. The shear flow distribution, the shear flow distribution in a single cell thin walled beam under the action of an arbitrary shear load Sy applied at the shear center S. This is what they mention, shear center Okay, as shown in the figure. The cell has horizontal symmetry with boom marked by 1 to 4 that carry direct stresses. Shear modulus G is the same for all the walls, and the area of the cell is total area they have given. This is the total area. Okay, how much it is? 1,35,000 mm square with respect to point A marked in the figure. The distance to the shear center. So they ask what distance of shear center from this point O. Okay, they consider point O. Okay, so guys, look here in this question. We have to take what the moment equivalence about point O, because about point O, if you take this about point O, we can take moment equivalence because they ask position of shear center from point O. Now look here guys, this they gave SY. Okay, what is the shear force they gave? SY. Now the distance is distance what? OS, right? Distance is how much? OS. Now this tell me about point O. SY create what? Clockwise or anti-clockwise moment? Anti-clockwise, right? Good guys. Now guys, if you look this, you can see section you can start from here, section 1 to 2, or you can start 4 to 3. From where you want to start? That you want to start from section 1 to 2 or from any? I am okay. 1 to 2 you want to start? Okay, let's start from 1 to 2. Now look into 1 to 2 guys. Your shear flow is what? QS 1 to 2, right? What is your length? DS, right? Now what will be the moment arm guys? About point O, if you take moment equivalence, what is moment arm? The 200 is given, so it is 100. Now guys, QS1 to 2, what will be your direction? This. So this will about point, it will give me what? Clockwise or anti-clockwise? Moment equivalence, it will be give me clockwise or anti-clockwise? See, this is my force direction, and about this point it will give me clockwise. Okay, clockwise. But what is QS1 to 2? Positive or negative? Okay, we will discuss first what? QS. So it is integrated from what? It is integrated from what? 0 to 500, right? The distance is how much? This is 500, right? So since it's what? Clockwise, so you will put negative sign and it is 0 to 500. Now your shear flow is flowing from what? 2 to 1, right? It is not from 1 to 2, it is what? 2 to 1, right? So what you have to do? You have to put here minus sign. How much is the value? 0.61 into 10 to the power minus 3 into SY. Now guys, it is multiplied by what? DS into 100. Right? About 1 to 2, is it clear guys? About 1 to 2, is it clear? Yes or no? Why? Okay, Shivendra Raj. See, we are going 1 to 2, right? So what will be your force direction? It is 1 to 2. Then you are taking about this point. So this 1 to 2 will be ideally creating what? Clockwise. But if you see the given problem, your shear flow is given in this direction. It is given 2 to 1. So that's why you have to put negative sign. Why this negative sign is there? Because this is counterclockwise, but this is what? Clockwise. Okay? Okay. Now guys, 2 to 3. 2 to 3 guys. If you look 2 to 3, right? So for 2 to 3, again 2 to 3, 2 to 3, it is going in downward direction, right? So about this point it will give me what? Sam, clockwise. So you can write minus, and what is the length? 0 to 200. Now guys, if you see the shear flow, it is flowing from 3 to 4, but we are coming 2 to 3. So again, inside it will be negative sign. So it is how much? Minus 2.86 into 10 to the power minus 3 SY into ds. What is the momentum? What is the momentum guys for this case? This is the momentum. So how much this? It is 500. Okay. Now guys, 3 to 4. 3 to 4 again. You coming from 3 to 4. 3 to 4, right? So about point 2, it will give me clockwise only. So negative, and it is how much? 0 to 500. Then value is given how much? Here shear flow is going 4 to, in actuality it is going 4 to 3. So again minus sign will come. So minus 0.61 into 10 to the power minus 3 SY into ds into momentum is 100. So guys, is it clear? Till 1 to 4, is it clear guys? Yes or no? Everybody, is it clear? Okay. Now guys, look here. For 4 to 1, 4 to 1, 4 to 1. Okay, this is 4 to 1, curved one, curved one. Now in curved one, suppose I took this section, a small section of length ds. Okay, and I want to find about point this. Okay, so this ds into shear flow will give me shear flows tangentially. Okay, now guys, this is what your momentum, right? So for a small section ds, your momentum is how much? ds into, they have not mentioned, it is not 100 actually, it is not exactly Mr. Shail, it is not exactly circular. Okay, semicircular, that's where people do mistake, and I also did mistake. How you find it is not circular? Because they given the total area. Okay, now guys, this total area is given, right? So what is the area of this, the curved part? What will be the area of the curved part? The area of the curved part will be what? 1 lakh, this 35,000 minus 500 into 100. 500 into 100. Now this will not be equal to if you just use 100 as a radius. Pi into 100 square by 2. It will not be same. Getting my point? Okay, that is the where they confused. So I just consider it as a rho. Rho is my what? The distance. Okay. So what will be your force? It will be QDS rho, right? Yes or no? QDS rho, yes. Now guys, you don't know. This is not the curved part, right? Or even for curved part. What we can do guys, we can multiply and divide by 2, right? So I can multiply now 1 by 2 ds into rho, right? So 1 by 2 ds into rho is what? This is the small area, right? This area of this triangle, right? Yes or no? So for curved part, guys, it is not straightforward. You have to use 2aq formula. Okay. So what it is? It is 2q ds and it is dA. So what it is? It is QQS dA. Okay. It is what? 2QS dA. Now what is the sense? Now guys, look into this. This shear flow for curved, it is going in this direction, right? About this point it will create what? Clockwise or anti-clockwise? Guys, quickly tell, clockwise or anti-clockwise? Clockwise. So it is positive or negative? So it will be what? Plus. So it is what? Q S, what it is? 4 to 3 integration dA. What is integration dA? So what is the integration dA? The integration dA of that area is what? This total area of this nose. So what is the total area of nose? This is how much? The total area of the section minus area of rectangle. Okay. So guys, here if I write in again shit. Okay, thank God. Yeah, I'm able to adjust. So what it is? It is plus, right? What is the value given? 2.14 into 10 to the power minus 3 sy. Okay, 3 sy. Oh, plus or minus, guys? Hey guys, everywhere first we did what? We It is negative, right? Or positive? No, it is negative now. It is negative, not positive. It is negative because it's again clockwise. Guys, again it is clockwise. So it is negative, right? Why positive? Because SY is creating what? This is negative, guys. Not positive. This is negative. Why it is negative? Because it is a clockwise, right? So what is the value? 2.14 into 10 to the power minus 3 sy. Now integration dA. Integration dA. It is not circular, Mr. Harsh. Again, I am telling now. If it is a circular, then your area will be this of nose section. But you calculate, if you calculate total area minus area of rectangular, you are not equal getting equal this. Okay, that's where they confused. Now guys, now everything is written. This hy cancelled. Guys, find the value of os. Find the value of os. So what it will become? Os equal to, so that will be 0.61 into 10 to the power minus 3 multiplied by what was the moment of 100, then integration of s 0 to 500. Yes, Ashish, what is your doubt? So it was 500. So that is what first I am writing for this. Okay. Then second part, second term, again minus minus become plus. It is 2.86 into 10 to the power minus 3. Okay. So what is the length? I think 200 is the length. 200 is the length. So 200, and what is the momentum? In this case, momentum is, I think, 500. Okay, then 0.61 into 10 to the power minus 3. Length is 500. What is the momentum? 100. Then the last, which is minus 2.14 into 10 to the power minus 3. And what is the area? It is 1,35,000 minus 500 into 100. So guys, can we find the value? Is it clear? So guys, how I found values? So guys, if you integrate, the integration of ds is s, the length is 0 to 500, so it is 500 minus 100. So here actually, if you see here, it should be like this is length. In first part it is what? This is length and this is what? Momentum. Then this is the length, momentum, this is the length, momentum, and this is what? The area. Now guys, if you look here again for curved part, what I did. So curved part, this is what the point about we are finding moment equivalence. So this is suppose a small section ds, right? So this is suppose some radius rho. So what is your force? Force is what? Qs into ds into rho. Now if I multiply rho and divide by 2, right? So what it become? Triangle, right? This is the triangle. So this is what? Small area dA. So you get, yeah, here one thing I think you missed. Here we multiply, need to multiply by 2. So it is what? 2 into, guys, here you need to multiply by 2. Here one typo is there, guys. This multiplied need to be multiplied by 2. 2 into 2.14. 2 into 2.14, guys, right? Because you can see here this 2 is there. So guys, here it is minus 2 into 1.4. Minus 2 into 1.4. What is the area? 500 into 100 or 200? I think area, check it. Yeah, 200. Guys, here it is 200. Area is 200. It is 500 into 200, guys. Rectangular area 500 into 200. There are so many typo mistake I do. Shit, not good. So 2 into 2.14 into 10 to the power minus 3 and minus 500 into 200. So guys, was it tough? If you know integration of ds, you're not required to write in that integral form. The total force is what? Shear flow into total length and momentum. So it's a one line question, right? Only you need to simplify this, right? But again, please guys, no, why Sanjeev you will take about 1 and 4? If you 1 and 4, if you take, then you will not able to use this now for curved section. This 2AQ, we are using 2AQ, right? For curved section, it will not be valid. So the best is about point O. Ravi Teja, you can see now in this why we multiplied by 2. You look here. For curved section, what we did, this is the point, right? About which we are finding moment equivalence. Now we consider this is what? ds, right? Now it's a curved, it is not exactly like radius. So suppose at this point your r is or rho is the radius, right? Okay. Now guys, this rho into ds, right? We have to write into qs. Now if you multiply this and divide by 2, what you see? This is what your triangle area, right? Because you have to take throughout this area, right? So when you integrate, what it become? 2qs 4 to 1 and then integrated integration dA, right? So it is what? It is nothing but 2aq. Same thing we are going to follow in Brad-Weather theory, guys. In Brad-Weather theory, what we find? We find torque. Okay. OS is the distance now of shear. This distance they ask now. Find OS is the distance. OS is the shear center position from O. So how much value you guys are getting? Now everything is in front of you guys. What is the value? Positive or negative? Tell me guys. See, first problem in this question was that node section was look like a Nishan. No, you are wrong. Others, please guys, quickly tell me what is the answer. So why I told let's start from 4 to 1? Why I told you guys understood? Start from 4 to 1 because we were going along shear flows. So that negative sign was not the concern, and also all would have been creating what? Anti-clockwise. So that minus minus part was not there. Now tell me guys what is the answer? Why I was going now? I'll erase everything and I'll tell this how to do these questions quickly. So I was going through 4 to 3, right? Why? Because my shear flow is in 4 to 3 direction. So about point it was giving me what? Anti-clockwise. Yeah, 197 is the correct answer. 197 is the correct answer. So what? So simple guys, it is Sy into Os. Now guys, my total force is what? Shear flow into length, right? For 4 to 3. So what is your shear flow? 0.61 into 10 to the power minus 3 Sy. What is the length? 500. Then what is the momentum? 100. And it is going in the same, right? Clockwise, anti-clockwise. This is also anti-clockwise, right? Then 3 to 2. Again it is going up. So it will create what? 3 to 3 to 2. Now guys, one thing I will tell you, whenever there is a boom section, okay, if your shear flow is constant, without integration you can do. I'll tell you that point at the last, just moment. Okay, I'll tell you one point here. Integration is not required. Why integration is not required? Can anyone tell why integration is not required? Because shear flow between these two section is constant. It is not in, it is not function of s. So without integration you can write. So for 3 to 2. For 3 to 2, what is the shear flow? It is 2.86 into 10 to the power minus 3 into Sy. What is your length? 200. What is your momentum? 500. What is the sense? Anti-clockwise. Then come 2 to 1. So for 2 to 1, it is what? It is 0.61 into 10 to the power minus 3 Sy. What is the length? The length is 500. What is the momentum? 100. And it is again counterclockwise. Then now if you come 1 to 4, it will be minus because shear flow is going from 4 to 1. But it is what? Minus 2aq. So 2aq, right? Because it's a curved section, right? So it is 2aq. So what is the area? 1,35,000 minus 500 into 200. Then what is the shear flow? It is 2.14 into 10 to the power minus 3 Sy. Clear now? This is clear, right? Yeah, no need to integrate if your shear flow is constant. If it is not function of s, directly that shear flow into length we can do if it is not function of s. And in case of boom, in case of idealized section, it happens like that only. So this is clear now guys, how to do quickly this. Everybody can write, right, this equation, yes or no, if they understand the concept. Okay, but guys, in exam many people did mistake in this. Why mistake they did? First, for curved section, they took it as a what? Circular. I also took circular. Okay. And second thing, they may not be clear about moment equivalence part and all. So 197 is the answer. 197. Okay. 197. So what it mean, Mr. Sanjeev? 197.2 mm. What it mean? Positive it came. What it mean? It came positive. What it mean? Your shear center is somewhere here, right? Yeah. Okay. Now guys, the last we need to discuss in this, for idealized section. Okay, for idealized section, so I am explaining you guys for idealized section what happened. For idealized is, let's start with this only, channel section. So channel section, suppose it is idealized like this. Okay, so T is thickness, these areas are A, this is A, boom areas are A, and this is B, and this is H. Now guys, what is going to happen in this case? This is A 1 to 2. So between 1 to 2, how will be variation? How will be shear flow variation? What will be your QS? My QS will be, in the case of boom, minus Vy upon Ixx sigma Aiyi. Right? Now guys, what will be QS 1 to 2? If you take this, it will be minus Vy into y is how much? It is h by 2. So it is h by 2 Ix x, and what is the area for first boom? It is A. So this will be your QS1 to 2. Now it is, tell me, it's a constant or variable? You will have some integral constant, right? This will anyway become 0, right? Because at free end your shear flow is 0. So between 1 to 2 your shear flow remain constant. Now 2 to, this is what, 2 to 3, 3 to 4. So 2 to 4 will also remain constant, and 3 to 4 also constant. So what is going to happen at 2 point? Can anyone tell? What is going to happen at point 2? There will be a jump. Shear flow jump will be there. Okay. There will be jump. Why jump is there? QS, if you find 2 to 3, why jump is there? Why jump is there? Anybody? Hmm? QS 2 to 3, why jump is there? Because this boom and this boom both will be added. So there will be jump in shear flow. So what it will be? If you find, what it will be? Minus Vy sigma Aiyi upon Ixx. Okay. So guys, here uh, you can write minus Vi Ixx, then again momentum is h by 2, so 2 IH into area A, then the previous shear flow Q naught. So in this case Q naught is what? Your Q1 to 2, and that will be added, so you will get double of this. So finally your shear flow QS QS 3 to 4 will be uh, minus of this, minus minus became plus na guys, because when you write y value it is h, right? So it became plus. Yes or no? It is plus. So it will be plus 2 Vy upon h a upon 2 I x x. That means the value will be what? Vy h a upon Ixx. So what? This is double of this value. So everybody, is it clear? For boom section, your shear flow, you can see it is double, and then again there will be decrement, and here it will become 0 at 4. So now guys, when you find your shear center for idealized section, you can take again moment equivalence about this point, and then if you take moment equivalence about that point, only 1 to 2 you have to consider, and again variation is not there, right? So you can directly multiply that B. If you find now your shear center guys, what you are going to do? If you find shear center in this case, what you are going to do? What will be your shear center guys in this case? So what it will be? Vy into zeta. This equal to what? Your shear flow 1 to 2, it is constant, and what we found, it is Vy into H into A upon 2Ixx, and it is for what length? B length. And what is the moment arm? It is H by 2, and we are doing it about what? Not H by 2. The moment arm is what? It is H, because if you find about this point, it is how much momentum? H. So multiplied by H. So what is your shear center? Zeta. For idealized section, it will be what? It is B H square. Then it is boom area A upon 2 I X X. Clear, guys? Any doubt in this? Any doubt, guys, for this part? Everybody? Okay, so guys, you can see this was creating clockwise. Clockwise, same I have done moment equivalence clockwise. So how I did? Now shear flow into total length into momentum, no integration required in case of idealized section, because shear flow is constant. So you got the shear center position. Now guys, I have done this part. If have anybody have any doubt, anyone have any doubt, whatever we discussed till now, shear center, shear flow for open section. In last question what? In last question 2 to 3. Yeah, arrow is up. Yes, yes part. What you see, we are going 2 to 3, right? But the shear flow is coming 3 to 2. That's why we have put negative sign when we did previous calculation. But if you go 3 to 2, you see in the here I have went 3 to 2. That's why positive. Clear part? If you move 3 to 4, because 3 to 4 when I got, my force is up, right? What is my force? It is qs into length, right? What is the length? 200. Now what is the momentum? It is 500, right? And it will give me what? This force about this point will give me what? Counterclockwise moment. Clear now? Anybody else have any doubt? Anybody else? Any doubt?